Yo, what's up everybody? I'm gonna start today's stream with some bad news, not too bad. We're only gonna do 3-hour streams this week as well, because I've got some other stuff I need to spend some time on. But hopefully it won't be less productive because of that. So we're gonna start where we ended up last week, and we're in the process of reworking and extending terrain data. We're pretty much just changing from having a texture 2D based backend to have a compute buffer based backend. Sorry, Cooler, I mean 3 hours per stream this week. So we're gonna do 5 streams, 3 hours each, Monday to Friday, if nothing unforeseen happens. So 15 hours in total. Gonna have to be crystal clear on that. But okay. So yeah, compute buffers instead of texture 2Ds. On the CPU, everything is implemented as it should be. So we can take a look at terrain data, where we have a struct which packs 4 bytes into 32 bits. And then we have this terrain data buffer, and here we have an array of these structs paired with a compute buffer. And this compute buffer is the one we send to the shaders. And we ended last stream with a problem. More specifically, this problem. So we instantiate the buffer with some data. We try to send it to the GPU, but it doesn't 100% work. So we're gonna start there. Kurosuke, what could be taking so much time off the important water duties? Life, unfortunately. Life is still prior 1, water prior 2. Okay. So what we have right now is something that looks like this. Let's see here. Let me just switch this one real quick. Do 256, 128, 512, 256, 0. And then we can do, let's just play from here. There is no life without water. That is objectively true, I think. Yeah, we need to double check this eventually, but it's not prior 1 now. Let's see here. Let's bring this one down. And then we can take up the debug mode, which looks a little bit like this, this, and this. And this is our grass data right now. We can see here that we do send something to the GPU. It's supposed to be... it's supposed to be very interesting. Perlin noise is what it's supposed to be. And we can also see here that we get it distorted in one axis. It seems to be X. Very interesting. So we can check here. Terrain data generate values. Here we generate some values. The messy part with this generation here is that we're currently we have to switch a lot between one-dimensional indices, two-dimensional indices, and then we also have a packing problem within this, because we have 4 bytes in 32 bits. So 4 separate variables packed into one variable. But that shouldn't be a problem on the CPU. So we set value index, and we generate a byte here. We transfer a one-dimensional index to a two-dimensional index, and we do it by I modulo size, because we pack it in the x direction first. And then we divide by size.x minus 1, because we want it as a normalized value between 0 and 1. For the y, we do I divided by size x. Which should also be correct. And we divide by size y. And then we set the data here at 1 point. I think we do it maybe when we instantiate it. Yeah, we do generate data, foliage. We do it with a Perlin noise data value generator with UV offset 0, UV scale 1, and noise scale 10. And then we apply the data. And when we do the apply, everything we do then is we update the buffer in question, so we pretty much just set the data, send it down to the GPU. Check here. We also have, yeah, this one. One sec. Yeah, I think we set this one as well, actually. Hopefully we don't, but we'll see. We apply the data here, send it to the GPU, and then, yeah, here, when we set a material, so set data in material, we set buffer, compute buffer. So it should be sent down the correct way. We also send in the size, UV scale, and UV offset. So on the CPU, I'm pretty sure this is handled correctly. Watching this result here, I can see something that boggles my mind. I'm gonna get to that one, but first, definitely. But first, let's see how it's handled on the GPU. And on the GPU, we have something called terrain data HLSL, terrain data base HLSL. Okay. Let's open it up like this instead. Shaders, shader utils, terrain-based data, and terrain data packing. Terrain-based data has a structured buffer with uint, terrain-based data. It has some size, UV scale, UV offset. And when we get terrain-based data, we usually send in a UV here, so normalized coordinate x and y between 0 and 1. And we call get terrain data from terrain data packing. So here we send in which data buffer we want to read, the size of the two-dimensional representation of this data buffer, and then the UV in normalized coordinates. So here we pretty much do a conversion between normalized 2D coordinates to one-dimensional non-normalized coordinates. So we send in x, y between 0 and 1, and what we want to get out is an index between 0 and the size of the data buffer. And then we use this index to get terrain data, and once again we pack one value into, or 4 values into one value. Each sub-value is 1 byte, so we need to get them out of it by some masking in bit shift, and then we divide by 255 because we want these values to be normalized between 0 and 1. Good morning, Geralt. Hope you had a wonderful weekend, man. So with this one explained, it's pretty straightforward that we have a lot of points where we might have a problem, right? We have a custom struct which we store the data in an array, and then we want to send it to the GPU. We also generate some data. When we generate the data, we transform the UVs, and that's only on the CPU. Then we send it to the GPU, and here we want to revert everything pretty much. So a lot of places where things can go wrong. Hopefully we can isolate them and test them each individually to figure out where it goes wrong. But I saw some interesting thing that I'm gonna get to first. Mr. Dima, what's up, what's up? Hope you had a nice weekend as well. So what I find interesting here is basically we use this one, get terrain data in terrain debug shader. The vertex shader here pretty much just transforms it, send it onto the fragment shader. In the fragment shader we do some grid calculations. Depending on mode, we are currently in grass, so we do grid position, grid value, and then when we are reading our value we want to print, we do this here. So get terrain based data, and then we output the green channel here. Mr. Dima, thank you for the follow as well, appreciate it. What we want when we visualize this data is basically that each pixel visualized here with this shader, so the inside of each grid element should have one green color only, right? So this area should be one shade of green, this one should be another shade of green, and so on and so on. What we see here is that we actually get a lot of different values, which makes me think that we are reading the UV in an extremely weird way, and I might know why. So let's see here. Terrain data, we do input UVs. Input UVs are just UV we assign to the mesh itself when we generate the mesh. So we can take a look at terrain patch mesh, and we have UV here. We just do I. We generate a lot of vertices here between 0 and resolution. For each vertex we do I divided by resolution, which means that we assign UV values between 0 and 1. We can also double check this by doing, instead of returning this, we return float4 input .uv01. And then we do this. So here we can see that we actually have correct UV values. X here, Y here. So the UV value is not wrong. It goes between 0 and 1 correctly in the X and the Y direction. So this input UV is not what's wrong. The question is what we do with it. So terrain data is equal to get terrain based data input.uv, get terrain based data UV. We multiply it with terrain based data UV scale and terrain based data UV offset. This is just to correct some mismatch we might have between scale and offset. I'm pretty sure this is not what's wrong. And to make sure this is not what's wrong, I'm gonna do this for now. So we comment it out and we show it. We still have the same problem. We can leave this one out. So let's see here. Get terrain data, we send in the structured buffer and the size of it and the UVs. Data packing. Here we use this UV, or we try to transform this UV from 0 and 1, X and Y, to a one-dimensional integer-based index. So most likely what's wrong is this one. But before we do anything with that one, I want to do return float4 data 0. 1. So we're not going to do any bit shifting or try to unpack the different bytes. We're just going to return it like this, see what kind of result we get. Should probably be interesting. Okay, but I think I get it. So if we think about it, we have something like we'll probably have data like this: 0 0 0 0 0 0 0 0 1 0 0 1 1 1 0 0, something like this maybe. Then we have, so this is how our 32 uint looks. We unpack it as a uint, which means that we get one integer from all of this, which means that we're going to have one very big integer. I think it's unsigned as well, so it's probably greater than, it's extremely big. So we just pretty much just get white here when we return. So we can't really, we know that we have data at least, but that we pretty much knew previously as well. We don't have any red data, but we do have green data, so data in the green channel. I wonder though, let's pause this. So probably where something goes wrong, based on the fact that each pixel here gets its own or multiple different colors is that we have something that is wrong here. And I wonder, so we can start by doing it the easy way. So we can do float2, yeah, let's do it as a float. Test is equal to, we start by doing float2 uv.x between 0 and 1 times size.x and uv.y times size.y. We can double check this one, so this one gets transformed to the GPU in the correct way. So that can be one thing that's wrong. But so if we have, I think we have a data that is 256 times 256. So if we have UVs that is 5.33, 0.4, by doing this here, we pretty much do 0.53 times 256, which is actually a little bit wrong. What we want to do is -1. I'm gonna explain why soon. So we want a UV value of 0 to map to 0, and we want a UV value of 1 to map to 255. Yo, what's up, Harukanen? I think we're actually only on day 190 since I started to... I'm probably only 150 since I started doing terrain. Hope you had a nice weekend, by the way, Harukanen. So basically what we do here is 0.53 times 255. Hopefully we... here we transform it into floats, but here we probably do a clamp of it, so we get 135 and 0.4 times 255, 102. So what we do here, we do here. And what we want to do then is we want to transform this 2D to one-dimensional. We store it in row first, so we do so basically column row. So if it would have been 135 0, we would like to transform this to 135. So I guess it's pretty much y times width plus x. Y0 we get 0, 135. So here we get 102 times 256. Yeah, and that should be correct. It was all right. We had a nice one as well. Yeah, mine was pretty good. Thank you for asking. And yeah, all right. That's better than bad, at least. So when I look at the calculations we do here to transform from 2D normalized to one-dimensional incremental, it looks all right. So why not? Could it be that our size here doesn't get sent accordingly? So let's test this one. We want size here to be 256 times 256. We can start by checking terrain patch first. Where do we have it? Here. GG Sammy, what's up? Hope you had a nice weekend. Love your videos. Thank you, appreciate it. Been trying to get the cell shader working in my project and no luck so far. Looks way better than my cell shader. Have you checked out my GitHub repository? Although that version is still for Unity 21.2. But it should hopefully work. If you don't get the source code I have on my GitHub to work, you can always just either create an issue where you explain the problems you're having with error log and images in a new issue on GitHub, or you can do it on my Discord channel. Yeah, I'm Unity 6, but just started playing around with it. Yeah, unfortunately, I'm not on Unity 6 yet, but I can probably help you anyway if you explain the problem. I do have plans on trying to convert this project to Unity 6 at the beginning of next year. I don't know if I'm looking forward to it just yet, but yeah, hopefully it will be quite painless. Okay, so here we send in buffer size name, buffer type size. So if everything here looks correct, I'm gonna try it on the shader side of things. So the question always when you work with shaders like this, how do we debug this? We can't just print it out, so we're gonna have to visualize, represent it in some way. We're gonna do, let's try and output it first. If it's 1, we can divide it with 256 or something and figure it out. And GG Sammy, thank you so much for the follow, appreciate it as well. So we can do terrain debug shader, grass, we return float for terrain base data size.x, terrain base data size.y, 0, 1. Yellow, yes. Okay, so this value is bigger than 1 and this value is bigger than 1. And if we divide it by 256.0 and 256.0, we should still get 1. I hope. Yes. If we divide it by 512, we should get half the yellow color. So halfway between black and the yellow we had. Oh, I think that looks to be correct. Yeah, this one is way brighter. We could also do, we could actually do it like this, which might be better. Terrain data size, if it's equal to 256, return white, otherwise we return black. Yes, so if we do 255, black. And then we can try the same with y. Yes. So the size... Oh, interesting. Size.x 255, size.y not. Right? Or no. Am I? Yeah, okay. Size Y works, size X works. So we have X 256, Y 256. So that is not the problem. The only thing left it could be is whatever we do here, unfortunately. This one. Exactly, Cooler SK. Savor this moment. Enjoy it. If I want to do... Let's do... Let's do this. Terrain debug shader. We calculate this one here. uint index. UV we change to input dot. Size we change to this, so then we have the index here. The index should go between 256 and 256 65. So then we can do return inverse lerp. Fuck, do I have one that is works with integers here? I don't think I do. But that doesn't matter. We can just do return index divided by 65536.0. Fucking hell. This looks fucking beautiful as well, I think. Hell yeah, it does. Do we have a difference here? What I want to do then is, let's do... Let's do index modulus divided by 256.0. Okay. This one I'm more interested in. Y is 0 down here, X is 0, but X grows in this direction. We take this index, we do modulus terrain base data size X, which what I'm looking to see, what I want to see here then is, or what I was hoping to see is black, a little bit brighter, and then we go like that, and then this one is black again, a little bit brighter, but we get something else interesting. And we can see here that this is the one that fucks it up. X goes from, or what is the weird issue we're seeing here? What am I missing? We pretty much get, we get 0. Let's see. We work with floats. Mod HLSL. Fmod. Yeah, that's not really what we want to do, is it? Index divided by 256. Oops. What the hell? There we go. So we have an index 65. probably don't want to do near, but floor. Because we have a floor, right? Do we? Floor, yes. So by doing this, we do get the y coordinates right in integer. So this leaves us with an integer between 256, 256. If we do divided by 256, yeah, then we get 256. But 256, we want to do 255. Fuck, am I... Yeah, so we get a value between 0 and 255, and it's currently the row number. So then if we want to print this one, we divide by 255.0. And this looks correct. So each row get its own color. We go from 0 to 1, I hope. Do we get a floating point mismatch here, maybe? No, we don't. We want to clamp this shit. Ooh. Ooh. Oh, yeah, because... Do we want to do 256 here? But if we do 256 there, we're never gonna get the white one, so I think it's this one. That should be 255. Or not. Okay, so what the hell is going on here? Let's see here. I want this one to be between 0 and 256 times 256, between 0 and 65,535. — 256 times 256, I mean. So if we have the last index and we do divided by 255, Rishiram, hi, I've been watching your videos since 23. Appreciate it, man. Thank you so much. 4N4C, thank you for the follow. Appreciate it. Okay, we have a little bit of a mismatch here when we transform between indices, but I don't think this is the biggest problem, but I still want to get to the bottom of it. So when we calculate a y coordinate, we want it to be between 0 and 255. Yo, what's up, Anaconda? So I wonder... Two, 5, 6. Actually, we're gonna try one thing real soon. I think the the weird offset we are getting, that this one being starts out very thin here and thicker here, might actually be because we don't do float to UV is equal to input.uv times scale plus offset. I want to see what happens if we do this UV transform. We still have this weird thing going on. We shouldn't be seeing this one. So basically what I guess what we would like to do is let's clean this one up a bit. We do it like this. U int x index is equal to uv.x times terrain base data size.x u int y index uv.y times terrain base data size.y. Let's skip this one. So both this one and this one should be a value between 0 and 256 right now. Right, so what we want to do is -1 -1. So now we have x index and y index between 0 and 255, which means that we can read every value in a 256 times 256 texture. So let's try this one. Return x index divided by 255. Looks beautiful. And the same works for y index, but in the other way. Okay. And then the last thing we do is we want to do y-index times terrain base data size dot x but not -1. If this is 0, we want 0. If this one is 1, we want 2, 5, 6. And then we do plus x index. If this one is this one is 255 and this one is 255, then we get 255 times 256 plus 255. And we get the last index. So that's beautiful. So this is correct. And then let's do divided by 65536.0. And then we get this one. And if I do one thing here, I also wanted to try if x index is equal to 255, what do we get? Uh, 255, okay. It's this one. Do I get no? What am I missing here? Did I choose the wrong? No, I didn't. Okay. Bigger than 100. I don't want to count this. Bigger than 200. Bigger than 25. 1, 2, 3, 4. 1, 2, 3, 4. Interesting. So we pretty much just get x indexes between 0 and 2, 5, 4. Have I fucked this up? 2, 5, 6. Did I... Let's see here. Terrain data. Width, height, size, we just return new vector to width, height. We set the width, height here. I'm thinking that that's in patch data, where we create these. Am I correct in that assumption? Instantiate data. Width, height. So width, height we send in here. Terrain patch. Instantiate. Terrain data. Instantiate resolution. Okay. We do resolution -1 here. Okay. What the fuck? What the fuck? I'm starting to think... What the fuck do we do this? Because I'm pretty sure we send in 256 here then, so we get 255 times 255. Okay. I'm not so sure we want to do this here. It's a little bit too early to do it, because that means that from this point onwards we're working with, as soon as we refer to size or length or stuff like that, we don't refer to the number of values in a collection, we refer to the number of indices, or we refer to all possible indices in a collection. So if we do size on the buffer, what we mean by size then is all of these indices are viable. Why the fuck do I do it like this? Patch bounds. One sec. Now I'm tired. Sorry about that, scratch that. Delta and patch bounds should definitely do resolution -1. We do this resolution is equal to resolution, so everything I said is wrong. We do it the correct way. We do. But I'm wondering if we do the mistake I thought we did here somewhere else. Because that's basically the result I'm seeing. Terrain patch data, resolution, width height. So width height is 256. I think this might be wrong. Or am I? No. This is correct. No. But do we need to do minus here? Okay, once again, if we have this one and we do modulus 256, 255, we still get 255, 256, we get 1. Or 0, I mean, which is correct. There's one stupid mistake somewhere here. This one is at most 254, which means that when this one is 1, and we tested this one. There shouldn't be a problem with this one. Do we never have UV is equal to 1 here? Do we have it if we don't do this? Is it the scale and offset that I send in that is wrong? Ooh, interesting. Okay. Okay. Oh, yes. Let's see here. I'm wondering if this could have anything to do with it. Let's see. 64 times 64. When we were working with this as texture 2Ds, we always wanted to make sure that we didn't read from the edge of the texture, but that we always read from the center of the pixel. And I'm wondering if that way of thinking is still here and screws it up for us. I wonder, maybe. UVX is never bigger than 1, that makes sense. But it's also never equal to 1. And we actually want it to be equal to 1. So if we take a look at this one, we want this pixel to have a value, a UVX of 1. So we should be seeing half of this one. But then again, yeah, we want this vertex to have a value of we probably don't want to floor it at least. Okay, that didn't help. When we assign UVs in terrain patch day, no. Resolution -1. So yes, UV is 0 to 255, 0 to 1. Okay, so when UV is 1, we actually get Yeah, 0.255 should have a UV of 1. We should have UVs of 1 here. Why we're not getting UVs of 1? Could very well be a floating point error here, so let's do util math, compare don't we have let's do UVX abs UVX. Let's do 1.0 minus UVX is 0.1 should result in a pretty big area, yes. 0.01. Delta is, we should probably compare to delta 1 divided by 256, 0.003. 0.003. Okay, so this should only be the last one. And we do get it. Okay. Yeah. Okay, we pretty much have UV that is 1 here. Okay. But not exactly 1. This comparison, however, okay, so this is correct. What am I messing around for? But yeah, it's probably the round that helps us. That's true. So if we have round here, I don't want to have round. It makes it... If we could do this without calling this method, it would be the best. But we might need to have it. But okay, this looks good. And Y index 254. Beautiful. Okay, so maybe it's the round that we're missing. So if we do uint index is equal to y index times size, which is 256, plus x index. We do it like this, and then we do return index is equal to 256 times 256, 65535. That is exactly what I want to see. Okay, beautiful. Index is bigger than 65535 minus 255. Hmm. 256 times 256 minus 1 minus 255. Yeah, bigger than or equal to. Okay, this index is starting to look good. It might have been the round that was needed all the way around. Okay, so let's test one index that is easy. So we want column 3 and row 2 maybe, which should be index 0255 256 512 515, right? Row, and then I didn't even do zero indexing here, but that's okay. Row 1, 2, 3, and then one column 2. Did I fuck it up? What did I do? 512, 256 times 2 plus 3, 515, 512. Not plus 3 plus 2, we should have 0, 1, 2, 1, 2, 3. This is index 256, right? I just want to make sure this is correct. And then the one over that one is 512. 512, 13, 14. Yeah, I just added one too many, so 14. This should be correct. 0, 1, 2, so 3, 0, 1, 2, yeah. Okay, so the indexing seemed to be working. If we do the rounding. So let's take a look here at terrain data packing. Here we do, we need to round this one and we need to round this one. And then we should be good to go. So what happens if we return this one now? Okay, nice. But this doesn't look entirely correct still. This looks like what you would get if you try to represent Perlin noise, but you have some overflowing going on. And underflowing, maybe. Yes, I'm questioning this. It might not know. I'm gonna try this. One sec. Harry, what's up? Data, the bit shifts should be 0, 8, 12, 16. Should be 0, 8. Yes, yeah, what the fuck? Yes, that is definitely true. That is definitely true. I'm also wondering, you say 0xff, shouldn't we be able to, shouldn't it be able to fill it out either way? Maybe not. There we go, thank you so much, appreciate it. Oh, you're entirely correct. But But here we go. So thank you so much. Appreciate it. There we go. Wow. And that's it. Data generated on the CPU properly sent to the GPU using compute buffers and some nice. Beautiful. Okay, let's do this now. Let's do. Let me just re-enable the UI. Where do we have it? Oh yeah, character playable entity show UI. I want to see. Okay, so now what we basically do now is we instantiate the scene, we instantiate all data. For the foliage channel, we generate the data as a Perlin noise and we send it to the GPU. We also have methods for in real time altering this data, and that's what I want to try right now, if that one still works with this new system in place. So if we do this and we add this one, Terraform foliage, let's just remove one. Foliage doesn't work. Height doesn't work, but okay, so let's take a look at this. So when we alter this, we should end up in terrain patch mesh. Maybe not terrain patch mesh. But terrain patch data. Move data, swap data, alter terrain data, blit. It's not a blit anymore. We do this, we calculate new value, we just add 10 here. That's true. Okay, so we don't care about brush strength, and then we set the value, then we update buffer sets the data. The buffer should already be linked to the material. I'm pretty sure. Okay, so why don't we get any altering of data here? We always, or actually we always add one. Add foliage. So everything is correct here. Terraform data, do we have anything here? Terraform data empty. Let's do it like this. Terraform data dot let's do center and bounds. We shouldn't have changed anything that alters anything before this, but let's try it. Yeah, we'll do. Range, I would like to have this one better, but 122, 134. Complete data update complete. Mesh data update complete. Fuck it. I wonder if we're gonna do this for now. It might be best if we do terrain patch. System serializable terrain data buffers. Struct serializable by default. Let's just do it like this. Native array should be okay. One sec, just gonna grab a cup of coffee real quick. Okay, back. Let's see. Do we have access to the information now? Terrain patch, terrain data, terrain data buffers, element 0, element 1, with height. Oh yeah. Let's do really? Oh yeah. What is it I'm missing in this case? As soon as we do public get, we get a compiler error here. I find that extremely weird. Which makes me wonder if we ever changed the date of it in the end. Original we can compare. Let's do this. Pros and cons compared between native array and then we do it like this for now, because I wonder if this works if we do terrain data data. Then we have no problems. Huh. I find that very weird. Maybe I don't know. Hopefully I will do no after this. Yeah, we don't have dispose anymore. So let's see, what do we have? Ground, here. Terrain data buffers. Oh, I still can't see. Really? Let's do it like this then, have it public for now. Yo, what's up Spires? Thank you for the raid, appreciate it. Hope you had a wonderful stream. Is terrain data serializable? Yeah, it should be, since we can see... I think it's the size and width we... Or am I... Terrain data, that's terrain data buffer. Then we have terrain data buffers. Public struct terrain data. I thought struct would be serializable by default. But is that the error I'm making? Let's try it out. There we go. Why did I assume... Thank you once again, Harry O. Why did I assume that structs would be serializable by default? Okay, we have a lot of data in here, that's true. Maybe I should have done this test with less data. RIP indeed. There we go. Let's pause this and let's see how everything works if we do environment, dimension 128, resolution 16. That should be okay. I just want to double check 16. How does looks good. Terrain patch data 16 times 16, still a bit much. Element 0. Yeah, let's do it like this. Okay, first of all, we care about Y, yeah. Water. Let's bring this one down, -1. Ibinks, thank you for the follow, appreciate it. We bring that one down. What do we have? It's extremely big. We're right in the middle, so we should be at 7-ish. 7 7. What is it? 16. $103 maybe. $87. We can actually do it like this, I think. We can alter everything. Foliage. I think we're altering everything now, and if I press E, zero 8. Okay, 0.8 is the one we're at, so that's 6 times 16 plus 7. I think I marked this correct. 103. I think that the end, yeah, we don't get any altering data here at all, I don't think. I could have made it, fuck it, let's quit one more time. Let's do environment, dimensions, 4. Let's make it a little bit easier. And then what do we have? This one should be 0 0. This one right here. 0 0. 127, yeah, looks to be all right. We can do this one way lower. What do we have here? 140, element 180, then 144, yeah, looks to be all right. So if we alter this one, yeah, we don't get any data change whatsoever. So I'm thinking, oh, here we actually do. Interesting. At this end we actually do. But this sucks. Altering this corner changes the first where do we have it here? 14.1 alters the first do we have action terrain, action terraform. We don't have any terraform data here. But okay. We're altering the wrong data, and we don't get the new data to the GPU. Maybe if we do this and this, no. And we have overflow as well. Yeah, we want to fix that as well. $21. 15. Actually, it doesn't really matter where we are located with the with this one. We always change those. I don't know not if it's this small, but do we change all data? No, we don't. Oh, here we can actually see it updating. Okay, so it's the conversion that is wrong. Do we only change this? 049, yeah we do. Ah, I get it. I get it. So the size of this one, okay. Up to a certain point. Okay, and we change it to the GPU. I don't know how quick it is, but no drops. Okay. Or actually, do we get drops? Yeah, we do. But that might as well be this one as well. Not too bad. Gonna have to test it on a bigger area later on. But okay, so I'm almost entirely sure that the problem lies at this method here. Get terraform data rows in circle, row number of steps, start index I, index, yes. This one should be this one has been tested too much. So I'm pretty sure the problem doesn't lie here, but it's actually what we do with this one. Start index. Yes. Yeah, what the hell. If we calculate the new index, we might want to use it as well. Okay, we change those two. Okay, I get it. Yes. So the problem here is that we want to do we do one step in the one step in the X direction too much, I reckon. Negative X, but that's okay. We should only change one when we have this marker. 0 here. But if we do this, yeah, then we get this. Okay, we're moving one step too little in the Z, maybe. Yeah, it's just a weird little mismatch here. That's not entirely true. We're doing this circular, so we get a weird circle here, that's it. Here we change the correct, I would say. Let's fix this by doing or let's extend this by introducing, we don't do +10 here, we do Terraform brush. Yeah, we don't want to set value, let's do alter value. Alter value, value index, int index, byte. Change. Don't we have a better term for this one? Whatever. Set value, value index, index, and we do value index. Plus change, but this makes this one into an integer. We could do Probably want to do byte math eventually, but for now we're gonna let Unity do its thing. So we change this one to an int. And then we want to clamp it. Clamp this one 0 255, and then we want to cast it to a byte. So the simple operation of adding or subtracting 2 bytes is actually take a byte, add a byte, cast it to an integer, clamp it between 0 and 255, cast it back to a byte. Yeah. No, that's not what I want. We always want to send in bytes here. But I don't like, now we do this in how many places? 2. Okay, and then I want to do, so instead of this we just do buffer alter value data index index, and the change should be terraform brush dot strength, which is a float. Fuck it, let's take a look at this one as well. This is not set in stone, but when it comes to when we work with these values on this end, I've always imagined it being like normalized values. So we work with values between 0 and 1, float values. 0 represents 0 and 1 represent the biggest value. So if we take that as an example of terrain data height, 0 is the minimum height we allow for our terrain, globally set I think, and 1 is the maximum height we allow for our terrain. Currently I think these are set to 0 and 1 actually. So when we transform, and the same goes for brush, we have a value, brush strength is a value between 0 and 1. So we could do probably, let's see here. Brush strength string. So probably want to do something like one sec. Byte value, yes, because our brush is also a texture. So what we do here, get bilinear value u v 0 r times 255. But that's not entirely, that's not all we want to do. Do I never call this one? Oops. Value, we want this one as byte. So we actually want to do here we get a red, and we want to do brush strength times this one times 255. So we read from the texture a value between 0 and 1. I'm pretty sure, yes. We multiply it by brush strength, which can be anything between -1 and 1. And then we multiply it by 255, so we get a value between. Yeah, this is a problem as well. Yeah, no, it's not. We get a value between. Oh, it might actually be. We get a value between. This one yields us a value between -255 and 255, but then we cast it to a byte, so we can only have a value between 0 and 255, which means that when we alter a value, the change we send in can't be represented by a byte. I guess it can, but then we can't go as high as 255. We can only go 127, right? -127. So having this one as a byte, I don't know. But what we could do is int, multiply by 255. We don't cast it to byte. Yeah. Cannot convert float. So is it something like this we want to do? Round to int, which means that in terrain data, when we do alter value, the change we send in will represent this one by an int. We don't want set value here, we want alter value. So that means that this one is an int, this one is a byte, so we do byte plus change. We're back to an integer here, clamp it, and throw it back to a byte. Opening up for the option of having a value between. So now when we call alter, we always do it with an integer. If we want to keep it as byte maths, we're gonna have to change it, so we send in a byte, and we're gonna have to handle. So we probably want to change this one to add value and subtract value. So we have two different methods depending on brush mode. I don't know which one is better, honestly. But the alter value here then is another thing that sucks here. If we go to Terraform data row, we have this one represent indices that are supposed to be changed in the terrain data area we have. And it's represented as rows. So for instance, where do we have it? If we have an area that is supposed to change, let's just do it like this. If we have this area that is supposed to be changed, when we represent it in data, it's this row as a struct, this row as a struct, and on and on and on. And that's because I eventually want to do, when we set values of an array, we want to set multiple values at a time. We don't do that right now. But anyway, that's how our change is represented in Terraform data row. In Terraform data row, we don't have... In Terraform data, we have these very nice UV rectangle space step size. I thought we had... I'm pretty sure it's these inverse lerp. Yes. Okay, so we have these. In Terraform data, we have these, which are pretty much... the UV for the brush, or the bounds rather. Let me explain what I'm trying to do, and so it makes more sense. Terrain patch data. When we want to get the value here, we want to change this one, so the alter value, then we need a UV coordinate to the brush, so it knows what pixel it should read in the brush. So pretty much Terraform brush value, and then we have UV here, so we need UV values. And that's so how do I want to do this? It's pretty much we want to transform this index to a UV index in brush texture space. Let's try and do something like Oh, we're not writing shaders now. Can we previously we did this as a blit, i.e. we sent down some boundaries and stuff like that to the GPU, and then we did a blit in a shader. We should be able to do something similar here eventually, right? You can alter structured buffers, right? We should be able to write here as well, with the only caveat that we need to do this after, if we want the data on the CPU as well. This should work. Hario, I'm not reading back data just yet, but we might want to do it eventually. So I was talking about alter terrain data blit. So previously how we solved this system was with a blit, as the name says. So think about worst case scenario, for instance, we would be, or let's assume that we alter a very big area in the terrain. So maybe we add grass values to a 256 times 256 area, so around 60,000 pixels that are supposed to change values. The thought was that this is definitely quicker to do on the GPU than to do on the CPU, so we just send some rules to the GPU alters the data, and that's that. Eventually, however, we might want that data back on the CPU. Or like, we always want the CPU and the GPU to match at least. So this is just about a question of, if we alter the data on the CPU, we need to send it to the GPU. If we alter the data on the GPU, we need to send it back to the CPU. Because if we alter a 256 times 256 area, we don't want to do this, I think. Yeah. So imagine yeah, we change a big area. We change the height of a big area. Yeah. Yeah, so this is actually how we did it previously, which I'm a big fan of. So we just take the Terraform brush, blit it onto data as render texture. So this was basically just the data but represented as a render texture, and we used Terraform brush material. And we had already set the proper parameters in this material. So we just did this split, but then unfortunately we had to do this. Which I don't know. We changed a big area real quick, but then this one is quite slow, so yeah, you know. But for foliage, for instance, if we just did we send down the parameters to the GPU, alter the data on the GPU, and then we do a async GPU read back, because we don't need the data on the CPU just yet. So then we just let this go in the background, and yeah, it's a-okay. But now I'm moving a little bit ahead. But it's nice to know that we could eventually do a lot of this data alteration on the GPU if we need to. Because once again, if we take a look at the different types of data we want to represent and work with and whatnot, it's a lot of different types of data, or what we use them for in the end is a lot, or is very different. So if we take the water related stuff, for instance, when our fluid solver runs, which is currently implemented as a threaded method on the CPU, but could probably eventually be moved entirely to the GPU when I'm comfortable with that. But let's take this one, for instance. The player adds water to the terrain, so our fluid solver starts calculating, and then we're doing a lot of calculations, and we change values a lot, and we do everything on the CPU. But every time we get to when we get to a stable state and we stop adding water, then we want to take all of that data and send it to the GPU. And then we don't need it on the CPU anymore. From that point onwards, right now, the GPU is the only one that works with it. The height and foliage works the same way, basically. But we're later on we're gonna have when we have our AI agents, we might get a data type that changes a lot more often and needs to be read way more often on the CPU. Nothing is set in stone. I don't know in the end how much how much we will let the CPU handle and how much we want the GPU to handle. But hopefully we will converge toward the correct solution at least. But okay, now we don't have the we can't rely on a GPU blit here, so we're gonna have to do it this on the CPU per pixel. So we need to calculate UV for the Terraform brush texture, and we can hopefully use Terraform data here to help us with this. So what we have here is bottom left point and top right point. Those are 2 points describing a square that is our affected area in two-dimensional index, or represented in as a two-dimensional index. Top right clamped and bottom left clamped, it's the same square, but it's clamped to only be specific to the current terrain patch we're working with. So yeah, this maybe doesn't make that much sense, but if we have a terrain like this that is represented by 4 terrain patches, and we have a Terraform box that is located here, i.e. we're actually changing 4 terrain patches, then this is bottom left point and this is top right point. But when we alter this terrain patch, we have bottom left clamped and top right clamped. Let me paint them in. So this, if I remember this one correctly. And we can probably use these to calculate the brush, I think. Yeah, if we want to calculate brush, for this point, we just want to do, so this one has an X and a Y, we just want to do inverse slurp, let's call it function of, as for X it's, yeah, inverse slurp between BLX TRX, but that depends. I don't know if we have, if these X and Y's are probably represented as the X and Y's for this patch, so it's not that simple. Now it's these. I'm pretty sure it's these. Oh, it was so much easier. What I think we can do is we take we get this one, we lerp. Yeah, so basically what this one and this one returns are the UV coordinates for this one and this one. So here we get roughly 0.5 and 0.5. No, actually we get, this one is 0, 0.5, and this one is 1, 0.5. Then we want to transform the one-dimensional integer index to this one. We could do this a little bit easier if we just did pixel per pixel. Yeah, let's do it like this instead. Terraform data, we don't do this. We do for int I is equal to 0, I is less than. But that's not entirely true. We do I is equal to Terraform data bottom left clamped.x, I is less than or equal to Terraform data top right clamped.x, I plus plus, j is equal to Terraform data dot bottom left clamped dot y, j is less than or equal to Terraform data dot top right clamped dot y, j plus plus. So now we have a two-dimensional index which we can transform a lot easier here. Derek, I couldn't remember for sure, but I think you have briefly mentioned the tessellation before. That will probably be a lot easier with the computer shaded workflow you're setting up. Yeah, the idea is to. This is also something that is not set in stone, but how we're gonna handle, like, because we definitely want. I want to support when it comes to the terrain and everything related to terrain, I want to support we're probably going to have two LOD systems, one for the meshes, or one for game objects and one for the terrain itself. So for instance, game objects like trees and creatures, we're just going to go with the classical LOD system of switching out the models if needed. But for the terrain, we want to do that automatically. So for a terrain patch in the horizon or way back, it might be enough to represent it by 12 times 12 or 16 times 16 vertices. And terrain patches close to the camera, we want the full resolution. Currently 256. and then we want to tessellate between those two depending on where the camera is. But that's way down the line. Okay, so if we do it like this, and then we have so what we want to do then, buffer.alter_value terraform brush.type.data index. The index here we're going to rely on I and j, and for the terraform brush value we want to calculate a value, right? So I think in terraform data, do we have a method for this? Get boundary rectangle space button left. No. I think we just want to do one sec. Derek, lol, I would watch you make your own nanite style solution. Hopefully we won't end up there, but who knows. Transform chords to, or let's call it this, normalize coordinates. Return new vector 2, not int. Fuck, do we want to do inverse lerp here as well? No, or am I doing this wrong? Isn't it as easy as doing... No, it's not. I think we want to do math inverse lerp. Bottom left dot x top right dot x x mathf inverse slurp top right dot y y. I think it's as easy as this. What the fuck is it? I think so. But then we want to send in this one to terraform brush.value. But yes, this one doesn't take something like that, I think. Let's see if we get a crash. Let's see what we get. Foliage should add 0.1. I don't know about this. Oh, we actually do get some errors. Or do we? Yeah, we do. Texture from a circular one from scripts. You can make. Oh, yeah. We don't. That explains it. Terraform brushes. Previously we did this on the GPU, so we didn't need this one. Let's try this. Should really disable the water generation when we're doing this. Come on. Yes, we get something at least. But we only do get it here, we don't get it here. We only get it when X and Y is positive. Is that it? Yes. Nah, we only get it on this square, I guess. Yeah, we do get it here, but a little bit of a weirder formation. Okay, that's good to know. We do get it here. Oh. Okay. We can see here that it works pretty good. So we have something a little bit wrong with the offset, I suppose. It's not too bad. Okay. We have a circular, I think we have Terraform brush for 1, 0, 1, 2, 3. I think it's this one, 64 times 64. We should be getting, this one should be the brightest. Fall off, then we should have these two as well. If we make it a little bit bigger, we do. Yes. We have this area here. We only do this one. I think we change all the pixels we should be changing. But we have a little bit of a weird offset going on. Okay, so two problems. The UV coordinate transformation is, we need to offset it in some way. The second of all, sorry about that, we can't seem to be able to change this part of the terrain, which is hella weird. First of all, I want to try. It could be that the brush coordinates are very wrong. So we go outside the brush texture. So let's do alter value minus 1000. When we have this brush size for foliage, I would like to alter this pixel like we do right now. That's pretty good. If we have this one, I would like to alter 9 pixels. Exactly like those. Beautiful. That's beautiful. And this one, what is it, 16? Beautiful. Okay, so when we get the index this way, it works. But it's slow as hell. I wonder if it's the for loop that's slow or... It's very slow. Okay, so when we calculate the UV coordinates to the brush, that's... So this part is what's messing it up. Normalize coordinates. We get the wrong coordinates to crush. Bottom left X, top right X. No. Fuck, why isn't this giving the correct result? X, Y. Okay, something is wrong here. Some little tidbit. But unfortunately I'm gonna have to get to the bottom of that tomorrow. Not being too optimistic, but I think we have pretty early tomorrow. I think we will be back to where we were, but now we have a much better system in the background behind the scenes, and we can probably start extending it. But yeah, I gotta run now. We're gonna do 3-hour streams this week as well because I've got a lot of other stuff to do. But thank you so much for watching, following along in this struggle. Appreciate it. Have a great rest of the day. Peace.